Okay, so today we're going to look at solving in 6.8 on Trig. And this is your more simplified solving. It really works a lot like what you would do to solve any linear equation. You're just going to do the opposite. So first, let's practice what it takes to just get the answer from the trig. So for example, it usually will say like solve each equation for 6 solutions, for example. And it'll start off with some really simple problems. For example, sine of theta equals a half. So we know that we have to look up where sine is a half. The reason we do that is because we have to inverse it to solve. The opposite represents the inverse. Now, why is that the case? Well, let's look at how they would show the work. You see, they would sine inverse both sides of the question. And because sine and sine inverse are on a letter, they cancel out. That's why sine inverse solves the question. But then we have to find, where is sine a half? Sine is a half here, and sine is a half here. So that is at pi over 6 and 5 pi over 6. Now we're going back to using the whole unit circle to find our answers, and we're not focusing just on 2 quadrants anymore. But that's only 2 solutions, and that's the only 2 on the unit circle that have that solution. So how do you find the rest? Well, you can go around the circle more than one time. So if I go all the way around the circle, from here all the way back, I've done 2 pi. So we add 2 pi to 1 1/6, which is 2 1/6, or 13 pi over 6. Then we add 2 pi to 5 6 over 6, and that'll be 2 5/6, or 17 over 6. Now once you've done at least this many in the pattern, you probably see a pattern. It went up by 4, then it went up by 8, it went up by 4, so guess what it's going to do next? It's going to go up by 8 and be 25 pi over 6, and then it's going to go up by 4 and be 29 pi over 6, and that's how you can get your 6 answers without continuing to add 2 pi. If you just do it twice so you can see a pattern. Let's try another trig work. So in question number 2, let's try tangent, because tangent always seems to be a problem that seems to take a little bit more work. First of all, this tangent has been rationalized. I can tell that because the square root on top has the same number as the denominator. So let's unrationalize it so we can find it on the unit circle. So I rationalized it and got the square root of 3 over 3. Square root of 3 cancels out these 3's, giving me negative 1 over the square root of 3. But I don't know if that negative goes on top or if it goes on bottom, because it's already been moved up possibly. So I would look for this answer in quadrant 1. All of them are positive, so that wouldn't be there. Quadrant 2, well, this is y over x, so y's aren't negative in quadrant 1 or 2. Y's are negative in 3 and 4. And for only one of them to be negative, it has to be here at the square root of 3 over 2, comma negative 1/2. For the negative to be on the x, it would have to be here, so that it's negative square root of 3 over 2, positive 1/2. So that's 11 pi over 6 and 5 pi over 6. So now that I know that's my 2 positions on my unit circle that have the y value as 1 and the other is the square root of 3 and one of them is negative, I start my list. Theta is 5 pi over 6 11 pi over 6, and I'm going to pause the video to answer the phone. Pesky phone calls sometimes. Anyway, if I add 2 pi to this, that'll be 2 and 5/6. So if I change that to an improper fraction, that'll be 17 pi over 6. If I add 2 pi to this, that'll be 2 and 11 over 6, and that'll be 12 plus 11 is 23 pi over 6. Let me erase this. Okay, back from the phone call. So now I need to look at this one up by 6, this one up by 6, this one up by 6. So I need to go up by 6, which will make it 29 pi over 6. And then I need to go up by 6 again, which will make it 35 pi over 6. So you just keep patterning whatever you get, and that'll show you the solutions for 6 different solutions. Now, there are some problems that might take you a little bit longer, and as we go through this, you may see that. For example, you might have a cosecant or a cotangent. That would take a little bit longer because of finding the angles. So let's look at cosecant. So first of all, I would change that to sine of -1/2 because it's harder to work with cosecant in solving. It's better to have sine, cosine, or tangent if you can. And so changing it to that gives me the opportunity to go look on the unit circle and try to think about sine being -1 would be here, and sine being -1 would be over here for the top number, because the second number is always negative in the bottom quadrant, and 1/2 is next to the x-axis. So that would be 11 pi over 6 and 7 pi over 6. So there's my first two answers. And why that's our first two answers again is you're inversing. Let's go back and talk about that again. You're inversing this side, and you're sine inversing this side. So theta is equal to whatever the sine inverse of -1/2 is. Right now, I have two solutions, 7 pi over 6 and 11 pi over 6. I need more, so let's add 2 pi. That's 2 and 7, 6. So if I change that to an improper fraction, I multiply and get 12 and add the top and get 19. Now that's already going up by 4, and that's already going up by 8, so I need one more to make sure I know what the pattern is. So let's add 2 pi to the next one. That's 2 and 11, 6. 2 times 6 is 12, plus 11 is 23 pi over 6. That went up by 4, so now I know my next one's going to go up by 8, and I get 31 pi over 6. The next one's going to go up by 4 and be 35 pi over 6. And the next one's going to go by 8 and get 43 pi over 6. But you don't always do that. You just do that when they ask you to in the directions. Normally you don't want 6 solutions, but it is possible to get them. Now let's look at just a couple more examples of this, but let's add an extra step. So sometimes there'll be extra numbers in your problem. For example, in question number 4, let's look at cosine of 2 theta equals 1/2. So I need to get rid of the word cosine, and I need to get rid of multiplying by 2. But because the multiplying by 2 is inside the cosine, I have to get rid of the cosine first. So I'm going to do cosine inverse. Okay, this crazy board's jumping around. Let me try again. So I'm doing cosine inverse to both sides. That makes the cosine cancel out on this side and give me 2 theta. And over here, I look up where is the cosine of half. Now let's go back to our unit circle. Cosine is a half when it's the second number. That's up here at pi over 3 and down here at 5 pi over 3. It's the first number. So I take each of those answers and set it equal to 2 theta to figure out what they will be. So how do you get rid of multiplying by 2? Well, normally we would say divide. But in this case, I have to flip multiply because I'm working with fractions. So I get pi over 6. Over here, if I flip multiply, I get 5 pi over 6. So I need more answers. So let's continue by adding 2 pi. That's 2 and 1, 6, or 13 pi over 6. Let's add 2 pi to this one. That's 2 and 5, 6. So that's going to be 12 plus 5 is 17 pi over 6, getting our improper fractions. Now let's see what our pattern's doing. It went up by 4. It went up by 8. It went up by 4. So it's going to go up by 8. And that'll be 25 pi over 6. It's going to go up by 4 again. So that's 29 pi over 6. And up by 8 again, which is 37 pi over 6. So even if you have something inside of the cosine, you still do the patterning the same way. Just takes an extra second to solve it because it's not just solve for theta. You've got to divide by whatever's in front, or add or subtract, or do whatever the opposite operation is. Let's try one of those with a half angle, because that was a double angle formula. How about we do sine of theta over 2 equals negative square root of 3 over 2. So first of all, I'm going to inverse it because I got to get rid of the sine. So sine inverse of sine of theta over 2 equals sine inverse of negative square root of 3 over 2. So you inverse both sides because that cancels out the word you already had. Because there's nothing there that says you're in the wrong quadrant. You're trying to figure out what quadrant to go to, so the sine and the sine inverse cancel. That leaves me theta divided by 2 equals sine inverse of negative square root of 3 over 2. So now I've got to go look up this angle. Now let's think about that. Sine is only negative down here in quadrant 3 and 4. And for the second one to be this angle, it has to be at 5 pi over 3 and 4 pi over 3. Because on each side of the y-axis, you have the square root of 3 over 2 point. So I'm going to set theta divided by 2 equal to 4 pi over 3. And I'm going to set theta over 2 equal to 5 pi over 3 and finish solving the inside now. So to get rid of dividing, you multiply. That would give me theta equals 8 pi over 3. And if I multiply over here, I'm going to get 10 pi over 3. Now I need to add 2 pi to see what that goes up by. So 2 and 8 thirds is 6 plus that's 14 pi over 3. And if I add it to 2 pi here, 2 and 10 thirds is 6 plus 10 is 16 pi over 3. So the first one went up by 2, and the next one went up by 4. The next one went up by 2, so the next one has to go up by 4 and be 20 pi over 3. So then the next one has to go up by 2 and give you 22 pi over 3. Will give you your 6 solutions. Now at this point, I'm going to stop getting 6 solutions, and I'm going to focus on a much smaller range to look at the angles for the next part. Most of what we're going to do in our next questions is going to be a lot more looking at working it backwards. But before we do that, let's look at a few decimal problems. And then I'm going to stop this video and say what sections in your book to do, and then I'll make a second video for the other problems. So the directions here are going to be use your calculator to solve each for 0 is less than or equal to theta is less than or equal to 2 pi. Oh, wait a minute. There's no equal to on that last one. It's just less than 2 pi. So I want to just use the unit circle numbers. I don't want anything bigger than 2 pi, which is 6.28 as my answer. I just want to focus on getting those first answers that you would get, like the ones off the unit circle, but decimal ones. And you usually round these to the nearest 2 places, 2 decimal places. All right, so in question number 6, let's do tangent of theta equals 5. In question number 7, let's do cosecant of theta equals -4. So first you have to bring up your calculator, and we're going to try and graph these functions. You see, each side of the equation is a function. So I can graph each side individually and see where they cross. For example, let me clear out my calculator here. I can type in tangent of x, and I can type in 5. One on each line, the 2 different sides of my equation, and go zoom 6. Now, that gives me a graph that has a lot more window than I need. I only need from 0 to 2 pi, so I might get too many solutions. Let's set our window. 0, 2 pi by halves. That's usually a good thing to go by. Pi divided by 2. And I don't know what y's to put in, so I'm just going to leave what I've got because I'm just wanting to make a shorter xy. Let me spell that again. An xy's, I want it to be shorter. So here it crosses twice, so I'm going to do second count number 5, and I'm going to move my cursor up to the top line and over to that first answer because I want to get the first one before I move to the second one. Enter, enter, enter. And I get theta is equal to 1.37. Don't care what the y value is because that's 5. I only care what the x value is. Then I'm going to do second count number 5. And I'm going to hit up and go over to the other answer. I only hit the up button once, so it would go to the other curve. So it would be easy to go straight across and not have to traverse those non-straight lines. And I get 4 don't want to write, 4.51. So it's not hard to put it in a calculator and see where it crosses. But when I'm asked to do problems like cosecant, I have to change it to sine. So I say sine is equal to -1/4 because I flip it and turn it into sine. So when I do that problem, I can't type cosecant. I have to turn it to sine. And that's why I want to flip it. And it doesn't matter if I put parentheses around that because that's all I'm typing. And I hit graph since I've already got my window set up. And I see it looks like it crosses more than one time. So second count, number 5, enter, enter, enter. I'm just going to let it go to the first one and see where it goes. And it looks like it went to the middle. So theta is equal to 3.39. Now let's see if we can find the other one. Second count, number 5, up. Whoop. Second count, number 5, up and over to the next one. It looks like it's way over here close to the edge. And there may be one right at the beginning. We'll go back and see because it might be. Enter, enter, enter. 6.03. And sometimes if you're not sure, you can just second count number 5 to lots of different places. Second count number 5. I'm going to hit the up arrow and go straight across and go all the way back over here to 0 and see which one it goes to first. If it goes to that 3.9, I know I've got them all. And it takes a while because it's in decimals. So it moves kind of slow. All right, enter, enter, enter. And it gave me a -1. I can't use that one. So I know that it would have gone to a positive one if there was one close by. And since it's got to be between 0 and 2 pi, that's between 0 and 6.28. And so those are my solutions. So calculator ones are much easier. So I'm going to stop this video, and I want you to work on the questions on page for 6.7, page 511. I want you to do 2 through 10 and 36 through 42 even. 36 through 42 even. I want you to practice the ones where you're getting 6 solutions, and then I want you to practice these calculator ones before you move on to the second video.